Hey guys, I hope you're well. Hope you're enjoying your first week down at Field Studies. Today we're looking at trig ratios. This is revision from year 9. This is not a lesson on how to do trig. Okay, you should have done that in year 9. You should know this reasonably well. This is more, I guess, resurfacing that information and making sure that we understand it. So if anyone else is watching this, please make sure you know how to do trig first. Right angled trig is what we're looking at to start off with. Then we'll delve into the non-right angled in a few lessons' time. Okay. So let's say for argument's sake, we have a nice little right angled triangle. We have a side here of 3 centimeters. We have a side here of 4 centimeters. We have a side here of X centimeters. Yes, I know you're probably yelling at me saying that's not trig. You can do that with Pythagoras' theorem. Absolutely. Okay. We wouldn't bother looking at trigonometry. In fact, we wouldn't be looking at trigonometry anyway unless we're looking for an angle because there are no angles given to us. So we would use Pythagoras' theorem in this instance. However, what would happen, let's say, if they took that measurement away? We only knew the horizontal of 3, we knew a hypotenuse, and then I threw in an angle like this of 40 degrees. That's what we start using trigonometry for. So trigonometry looks at sides and angles within a right angled triangle. Down the track, of course, we'll go into the non-right angled triangles as well. So would you know how to do this question? Can you remember back to year 9 on how to do this? You might remember little things such as sine, cos, and tan. Okay, or sine and cosine and tangent. You might remember things with theta as the unknown angle. Okay, and you might even remember some little rules that could help you. So for example, if we find the angle of sine 40 degrees, we'll always know that it will always have the same ratio as the opposite side over the hypotenuse. I'm going to write that down. And it's not a bad idea for you to do this as well. If we figure out what cos of 40 degrees is, that will always be the same value no matter what happens of the adjacent side. Let's call that adjacent over the hypotenuse. And if I type in tan 40 in my calculator, that will always tell me the same value of opposite over my adjacent. Now, these are some nifty little rules. You might know this as, of course, SOHCAHTOA. Okay, now SOHCAHTOA is simply going to help you to remember the 3 ratios. Sine is opposite over hypotenuse. Cos is adjacent, ADJ, over hypotenuse. And tan is opposite over adjacent. Okay, so there's lots of ways you could do this, gents, but certainly SOHCAHTOA is probably the most universal that we know. That's going to help us to find one of these sides. So we know, for example, that if I look at this first rule, and the reason I look at that one, I guess, is because we've got our theta is 40 degrees here. We have our opposite side, which of course is opposite the angle in question. Our hypotenuse, well, it can only be one side. It's opposite the right angle is this side here. So in this instance, this triangle is really looking at that sine rule. Okay, now I know that if I type in my calculator sine 40 degrees, whatever answer that generates will be the exact same answer as if I do 3 over x. Okay, now let's say I'm going to chuck this in my calculator now. I'm going to type in sine 40. I should have used a nice exact number, shouldn't I? But there we go. We get an answer of 0.642 dot to dot. Now, that equals the same answer as 3 on x. Now, I'm not going to solve that just yet, but you can now see that we've actually created a linear equation. We can times by the x, we can divide by the 0.642. We can now solve our equation to find out the value of x. So the whole idea of using trigonometry, using these ratios, they will enable us to find the sides of a right-angled triangle, or down the track, the angle of a right-angled triangle, or in fact, sides or angles of non-right-angled triangles. But what do we need to remember for today? We need to remember SOHCAHTOA first of all. I like SOHCAHTOA. And then we need to know what that actually means, and we delve with questions. I hope this is sort of regenerating some of that knowledge back from year 9. We're going to look at 3 questions, 3 different questions. Of course, one's going to be a sine, one's going to be a cos, one's going to be a tan. One's going to be tough, and I reckon you know which one that's going to be, for a couple of different reasons, of course. Pause the video, just see if you can remember how to do this. Again, not teaching you how to do this, I'm helping you to remember. Okay, pause it and come back to me. All right, how'd you go? Hopefully you remember how to do some of this stuff. If not, that's okay. So the first thing always, no matter these three questions, I want to identify which rule am I using, sine, cos, or tan. Of course, if I go back up above and I draw in a little theta, okay, the side that is opposite the theta is always called my opposite. The side that is adjacent to it, of course, is called the adjacent. And we always know the hypotenuse is the longest side, or it's opposite the right angle. So that's the first thing I need to do, is figure out which rule am I using. So in this instance, of course, we have the x, which is the adjacent side. We have the 10 is the hypotenuse, of course, which means we're using that CAH, the car. Okay, and that means we're using cos theta equals my adjacent over my hypotenuse. Now, if you want to write that rule down, by all means, go for it. By now, you probably don't really need to do that. You should be writing straight away cos 50 equals my adjacent, which of course is x, and of my hypotenuse, which is 10. That's the first line that I want to see. No matter what you do, I want to see it in your books. The next part, it's up to you. If you want to write the answer down, by all means, go for it. But I often will do this. I'll now get rid of that divide by 10 so I can isolate the x. Opposite divide by 10, of course, is multiply by 10. So 10 times cos 50 degrees. Now you can put a little degree sign in. You don't really need to do that. And all I'm going to do now is type it into my calculator. I'm going to type in simply 10 times. You don't really need to put the times in there, to be honest with you. And we're doing our cos of 50 degrees. Now, one thing I'm going to want to notice, now on my screen, it's a little bit hard to see. You want to make sure your calculator is in degrees mode. I haven't checked mine because on my computer, so I'm going to check it now. So on your calculators, gents, that shift mode or shift setup, okay, I'm going to make sure it says number 3 is degrees. And when I press that, okay, we should make sure that we have a little D at the top of our screen that we are in degrees mode. Later on in year 11, 12, you use radians, but certainly we want to use degrees. Okay, I'm going to type it in again just to double check for my own safety, of course, that I have the right amount in there. That wasn't degrees, not radians. It looked right. Okay, we get 6.427876 ... Okay, now I wrote that whole thing down, of course, because in our question it wants 3 sig figs. Okay, so the third number here that is non-zero, well, the first non-zero number is the 6, then 4, then 2. The 7 says it rounds up, so I'm getting an answer of 6.43 centimeters. Perfect. Okay, so hopefully you're starting to remember this. Okay, our trigonometry. Okay, from year 9, SOHCAHTOA. Sine equals opposite over hypotenuse. Cos equals adjacent over hypotenuse. And then we have our tan, which is opposite over adjacent. Find your rule and then simply substitute and solve. It's not that hard, just identify which rule you're using. Okay, second one. First step, identify which rule am I using. Well, if I'm a betting man, I'm not, but if I was, I'd say be sine or tan because I've already had cos and I'm told you I'm going to give one of each. However, let's do it properly. So we have, in regards to the 40 degrees, we have the opposite side there. In regards to the 40 degrees, I also have the hypotenuse side. That's the easiest one to find. There's no point writing in adjacent. There's just no need for it. In fact, I think if you write that in, it starts to kind of play around a little bit because I want to figure out, when I write those two sides down, which rule uses those two things. Well, thinking about my SOHCAHTOA, SOH, that uses the O and the H. We saw over here the car was the adjacent hypotenuse. So see how I can identify my rule pretty quickly. I'm now going to apply it straight away. Sine 40 degrees equals my opposite side of x over my hypotenuse side of 10. Okay, and it's a very simple process from here. Very similar to that last question. Want to find what x is equal to? So I simply get rid of the divide by 10 is times by 10. 10 multiplied by sine 40 degrees. Now, just so you're aware, sometimes in senior level mathematics, instead of writing a times symbol, we write like a little decimal point, but it's kind of like midway. It just helps me, if I'm using x's, I don't like to mix x's and times together, so I use a little dot there. It just means multiply, just so you're aware of that. You can use brackets as well. I could do that if I wanted to. Anyway, I'm going to get my calculator out. I'm going to type in 10 times sine 40 degrees. You don't need to put the degrees in there, by the way. You can if you want, but there's no real need in this instance. And I get an answer, x equals 6.42787 ... I wonder if you notice anything. 6.43. Notice anything? They're the same answer. That's something that's going to kind of link in later on. Those two things are exactly the same value. That's pretty cool, right? If they're the same value, I wonder if you can figure out the relationship there. Interesting. That's food for thought later on. I might be able to tie that back in when we start looking at some harder questions down the track. Okay. Last one. Hardest one. Did you figure out why it was a hard one? Not just because it was the tan rule. It is a tan rule, of course. We have our opposite sides, opposite the angle given. We have our adjacent side because it's next to the angle given. So, of course, we're using TOA. Okay, so tan theta, or tan, my angle, equals my opposite over my adjacent side. You most likely would have written it straight in as tan. Now, you can see why this is probably a little bit more complicated because I now have degrees and minutes. It's a part of a degree. Okay, my opposite side, of course, was that 10, and my adjacent side was x. So there are two distinguishing things that make this one harder. First of all, I've used an angle that's like a decimal, but not quite like a decimal. It's a part of a degree. Remember we have degrees, minutes, and seconds. Like time, the maximum is 60 minutes, then goes into a degree. Or 60 seconds goes into a minute, 60 minutes goes into a degree. We'll look at how to type that into a calculator, of course, if you've forgotten. The other part, and this is probably more so why this question is a bit more challenging, is that the unknown is on the bottom of my fraction. Now, can you remember what happens here? To be honest, there's not a whole lot difference because all I'll be saying is, well, I can't deal with the x on the bottom. So what's the opposite of divide by x? I'd say times by x. So x times by 10, 40 degrees and 38 minutes equals 10. Problem is, of course, here I haven't solved my question. I haven't isolated the x on its own. What's the opposite of times 10, 40, 38? Well, hopefully you have said it is divided by 10, 40 degrees and 38 minutes. Now, I'm going to say quickly there, because obviously the next bit's going to be very easy. We're going to type this into a calculator. Can you notice anything that has particularly happened in these two lines of working? Is there a quicker way that we could do things? And then what you might recognize, generally speaking, is that if the unknown is on the bottom, it's the denominator, it can actually switch with the tan, 40 degrees and 38 seconds. They just switch around. Because think, if you're timesing by one, you're dividing by the other, they're replacing each other, they're switching positions. Doesn't really matter, just do it the way I did it the first time and things will be okay. Of course, I want to top this out now. I'm going to do 10 now. This is the other part, this is a little bit more challenging. I'm going to do 10 over, okay, you can do divided by if you wish, and I'm going to type in 10. Now, I can't show you my calculator, unfortunately, but can you remember how to type in 40 degrees and 38 minutes? Well, we can type in the 40 degrees like normal, that's the 40, and then remember, you have this little degrees button, okay? It looks like this. I often used to call this the bubble button. It looks like a whole pile of bubbles, right? We call it the bubble button. Some people on their calculators had the DMS, degrees, minutes, and seconds button, but that's kind of been phased out. We more likely will have that. And so we actually type in that for the degrees, and then we press it again for the seconds. And what you'll see on your calculator when you do it, I'm going to do mine now. I'm going to do my 40 degrees. What we had 38 minutes. I'm going to press it again. Okay. Now, most of the time, most calculators will come up with like a little kind of a degree symbol, like that kind of thing. Technically speaking, it should say this, 40 degrees and 38 minutes, like that. That's how we generally write it. If we go to seconds, we do a double dash, but your calculator will kind of just go degree. That's just the way we have to roll. I'm going to press equals. And if you don't press it after each one, so for example, if you only press it once in between, you're going to get a math error anyway. So you can't go too wrong, I think. Anyway, we come up with the answer in this instance of x equals 11.6534 ... to 3 sig figs, 11.7, and that was centimeters. And hopefully you recognize the other one in question 2 was millimeters. That's my answer. Now, I wonder if you got those 3 answers right at the beginning. If you did, then I don't need to say any more to you guys. You need to just push on and crack through some of the questions for today. If you struggled, if this is like new to you, you went, oh, I didn't do this last year in year 9 or year 8, sorry, I didn't do the accelerated program, I'm a little bit missing, I'll add another video that you might want to watch as well. But I mean, to be honest, this should give you a pretty good grounding of how trig works with sides. Next lesson, we'll go into trig with angles. Very similar, but there is, of course, a slightly different process when we find the angle. Have a crack at these questions. That last one, of course, was quite challenging because you have the unknown, the variable on the bottom of the fraction, the denominator. That's where those questions get a little bit more tricky. And remember, if you have degrees and minutes, just press that little bubble button a couple of times and make sure you can understand how to do that. Apart from that, then that's our lesson. I hope you're well. I hope you are enjoying your first week, and I'll speak to you soon.